Hello guys, welcome to ACE Online and special welcome to the ACE knowledge sharing session and previous year questions on ISRO examination guys. I am going to deal with strength of material for both civil and mechanical engineering students. Let's start with coming to myself, Hajratwali Sir. I am the faculty at ACE Engineering Academy. These are my credentials. I secured 14th rank in GATE, 45th rank in ESC. I have done my masters at IIT Bombay and I worked at GE Global Research for 9 years guys. And I have been teaching from past 14 years guys. So I know exactly what to teach, what not to teach, where to focus, where not to focus guys. So just follow our content guys. There is more than enough. Coming to strength of material guys, they are not giving too many depth questions in strength of material guys. So they are giving surface level questions only. If you compare with the GATE with ISRO, so what I can able to say is guys, ISRO level questions are almost I can say 60 to just 70% level of only the level of GATE questions itself. So if you prepare well for the GATE, you can easily able to also answer all the questions of ISRO as well guys. Okay, straight formula based, some directly theory questions they are going to asking you guys. So it's a very easy for for cracking the exam with the help of strength of material guys. Okay, without further delay, let me start the session. Next, coming to the first question itself guys. Everyone, please read the question carefully and if possible, try to share your answers in the options. In that way, you can able to engage in the session guys. Share your comments also. Okay, yes, let's start guys. If Poisson's ratio for a material is 0.5, Poisson's ratio is given as 0.5 guys, then elastic modulus for the material is how much is asking sir? The 3 times its shear modulus, 4 times its shear modulus, equal to shear modulus and intermediate guys. How can we find out guys? This way can done easily with the help of only one formula guys. Asking relation between elastic modulus and shear modulus guys. What the formula? E equal to how much guys? E equal to 2G into 1 plus V. Yes or no? E equal to 2G into 1 plus V. 3 standard formulas are there guys. That equal to E equal to how much guys? 3K into 1 minus 2V. Next, E equal to how much guys? 9 kg by 3K plus G. Guys, questions comes very frequently from these 3 formulas itself. Now, this question belongs to formula number 1 guys. Here, E equal to 2G into 1 plus V. How we can able to solve? E equal to 2G into 1 plus V. What is the Poisson's ratio guys here? 0.5. 0.5, which means that 1.5. 1.5 into 2 is how much guys anyone? So 3. So answer equal to how much guys? 3 times of rigidity modulus. So it's option A is the correct answer guys. I hope this is clear. Next, if I section shear load is resisted mainly by, if you take I section guys, where the shear load is resisted mainly guys, you please think and give your answers guys. Let me check your answers, please. Share your answers guys. Yes, it is the web guys, it is the web. Very good guys, very good. It's the web only, not the flange guys. Flange carries guys most of the shear load. Sorry sir, web carries the most of the shear load. Who carries most of the bending load guys, anyone? It is the flanges will carry guys most of the bending load. Why? Because if you check it guys, the typical I cross section, it is a typical I cross section guys. How is the shear stress variation guys? Shear stress variation is how it is? Yes, Because as I told you, stress means resistance, guys. Which part is resisting more? Yes, my flange, my web part is resisting more. As web part is resisting more, this is carrying more shear load. Suppose if the same question, if they twisted like this, for I section, like for bending load is resisted mainly by, then answer should be what? If it is resisted mainly by, tell me sir, it is the flanges at that time. Why? Because for this one, guys, this is a typical shear, like bending stress variation, guys. So most of the stress is carried by flanges only. I hope this is clear, guys. But he has given shear. Shear means what, sir? Anyone? Only web. Web is the right answer, guys. That's great. Next, if a material expands freely due to heating, it will develop. Tell me, sir, if a material expands freely due to heating, it will develop thermal stress, tensile stress, no stress, or bending, guys. Without second thought, give me the answer, guys. It is the no stress, summa. It is the no stress, guys. As I told you, sir, why? Because it is expanding freely itself, guys. Generally, when we get the stress, whenever something happened not according to your wish, the stress will be developed. Yes or no, sir? But here, what is the wish of a material? When I try to heat, it will expand. That is the wish of a material. If you restrict that extra expansion, guys, then stress will be developed. Are you getting an answer, everyone? Yes, sir. Here's a completely free expansion. This is the keyword, guys. This is the keyword. The right answer here is, guys, no stress, guys. Yes. Next, please go through this question. An unconstrained thin circular disc has a concentric hole on it. This is the question. Most of the students, guys, try to give the wrong answer. Please think carefully and give the answer properly, guys. There is an unconstrained means it is not restricted. This is a disc I am having, guys. Concentric disc. Concentric disc, guys. There is a hole in it. On heating, the diameter of the hole will be, on heating, guys, the diameter of the hole will be, guys, increased, decreased, remains constant, first increased and then decreased, guys. He is not asking diameter of a disc. Here asking diameter of a hole, guys. Diameter of a hole he is asking. This is the diameter he is asking. This is the diameter. Think of it, guys. You can do it. Try. Let me check your answers, guys. Very good, guys. Increase or decrease? Yeah, I know that most of the students will think the same manner itself, guys. Yes, the right answer here is, guys, the diameter of the hole is, guys, increased. Diameter of the hole is increased, guys. You might be thinking, sir, when I try to heat, it will come this side, na? It will try to close the hole. No. Generally, when I try to heat, what happens exactly, sir? It will try to expand. Simple logic, if it is completely solid disc is there, when I try to heat, what happens? It expands. The size will be increased, guys. Similarly, when I try to heat, this inner circumference will be increased or decreased when I try to heat. The inner circumference will be increased or decreased, guys. It will be increased. The inner circumference will be increased. The size will be increased, guys. If you are thinking it is coming closer, means inner circumference is reducing. No, it will never happen during heating, guys. The right answer here is what exactly? Option A is the right answer, guys. Next, please go through this one, guys. Robert Hooke discovered experimentally that within the elastic limit, what happens, guys? Within the elastic limit, guys, what is going to happen? Think of it, guys. Within the elastic limit, guys, tell me, sir, what is according to guys, Hooke's law? The stress is directly proportional to strain, that too within the elastic limit only. So I can write the stress by strain equal to how much, guys? Something constant, amma. According to given options, guys, which one is the correct one? Option B is the correct one, guys. I hope this is clear for you, guys. Next. Yes, please go through it, guys. A circular rod, please go through each and everything, guys. A circular rod of 100 mm diameter and 500 mm length, guys. I am having a rod which is having 100 mm diameter, guys. So diameter is given as 100 mm, guys. Diameter equal to 100 mm and 500 mm length, guys. So length equal to how much, anyone? 500 mm, guys. Is subjected to a tensile force of 1000 kilonewtons. Take care of the units, guys. 1000 P. Here also P. How much, guys? Anyone? 1000 kilonewtons, guys. 1000 kilonewtons. Determine the modulus of rigidity. Determine the modulus of rigidity if E given, guys. If E given. First of all, this is completely useless data he has given. Completely useless data he has given, guys. What is the use of this data? Completely useless, because he is asking G equal to how much he has given E. So how can you solve it, guys? Direct formula, E equal to 2G into 1 plus V, guys. Here Poisson's ratio given, guys. Anyone? If Poisson's ratio also given 0.3 itself, guys, how much is coming? I can able to say 2 into 10 power 5. Listen carefully, sir. E equal to 2 into 10 power 5 equal to 2 into G into 1 plus V. 1 plus V means 1 plus 0.3, guys. So how much is coming here? 2 getting cancelled. So I can write G equal to 1 by 1.3, guys. 1 by 1.3 into 10 power 5, guys. 1 by 1.3 means how much, guys? Approximately, guys. It is 0.769, guys. Approximately 0.7692 into 10 power 5 Newton per mm square, guys. The right answer here is option C, guys. Sir, why they have given this data, sir? Sometimes questions comes like this, guys. They flooded with a lot of useless data. You keep on thinking of why this giving something will be relevant and all, guys. No. If you are conceptually perfect now, you can eliminate what is the useful data, what is the useless data, guys. Here, the moment I started, I understood that is asking G, I know E, formula I directly I know, guys, E equal to 2G into 1 plus V, guys. So whatever data he has given is completely useless data. I hope this is clear, guys. Okay? Yes. Now, please go through this question, everyone, guys. This question, guys. A rod of length L and area of cross section area A has a modulus of elasticity as given, guys, and coefficient thermal expansion is alpha. Then one end of the rod is fixed and other end is free. One end is fixed, other end is free, guys. If the temperature of the rod is increased by delta T, which means that, guys, this is the rod is there, one end is fixed, other end is free. When you try to heat, what is going to happen? Okay, this is what exactly he is asking, sir. Stress developed in the rod is E alpha delta T. No. What is the stress developed equal to how much, guys? That is when stress developed, when both ends are fixed. He is correct, amma. When both are fixed, guys, E alpha T is the correct answer, guys. You can check our classroom notes. Case 1 we discussed, guys. Case 1 in our classroom notes, guys. Sorry, case 2 we discussed, guys. He is talking about the case 1 what we discussed in our classroom notes, guys. If both ends are fixed, E alpha T will be coming. But one end is fixed, other end is free means what is going to happen, guys? Anyone tell me, sir? What is going to happen, guys? Here, see, stress will be 0, but the strain will be present, guys. What is the strain value formula? Due to thermal strain, what is the formula, guys? Alpha into delta T. Change in length, can you please tell me, sir? L alpha t is the change in length, guys. Now, if you can check it, guys, the stress developed in the rod is 0. The strain developed is how much, guys? Alpha into delta t. The right answer here is option C, guys. I hope this is clear. Next, please go through it, guys. For isotropic materials, the modulus of elastic tension has given. Shear, see similar kind of repetitive questions, guys. I am telling same. I am telling guys one more time, guys. So those three formulas, guys. This year also I am expecting one question from these three formulas. If we check all the PYQs, guys, the questions on E equal to 2g into 1 plus v, E equal to 3k into 1 minus 2v, E equal to 9 kg by 3 kg. From these questions are very much repetitive, guys. Should be very careful. Here, according to this one, guys, E should be equal to 2g into 1 plus v. Without second thought answer, option B is the correct one, guys. Next, yes. Try to solve this question, guys, everyone on your own. Please, I am giving you time. Please read the question, guys. Try on your own, guys, everyone. Try on your own. Read the question carefully. Try on your own, everyone, guys. Everyone, please give me the answers, guys. Share your answers. Good, guys. The stress produced in a wire of diameter 6 mm. It is bent around a large cylinder of diameter 2 meters. Can be obtained as a modulus of both wire and cylinder is given as, guys, 200 gigapascals. The stress of the material is given below. The stress strain curve also has given, guys, has given E value has given. Then is asking, guys, the stress produced in a wire of diameter. How much is the stress produced in a wire of diameter equal to how much, guys? 6 mm. When it is bent around a large cylinder, you remember, guys, in theory of simple bending, I have clearly discussed here how to solve this one. You remember, guys, you know this formula, guys. Excuse me, Radha, may I follow you? This is a Radha formula, guys. From this formula, he is asking what exactly the stress produced. So bending stress he is asking, guys. But does he given bending moment? No. So from where I have to do it, guys? From this formula itself, sigma B equal to how much, guys? Anyone? Ey by r. Ey by r. But what is mean by y? What is mean by r? You should be very careful, guys. Here it is a bent around a rod, guys. What is the large cylinder of diameter 2 meters, guys? So radius equal to how much, guys? Anyone? I can say 1 meter is the radius, guys. On top of this one, what happened, here there is a wire which is bent around this one. Wire which is bent around this one, guys. There's a wire is bent around this one means, guys, tell me what exactly, sir. So what is the y value, sir? Diameter is how much has given? 6. So y should be half of this one, guys. This is the y. So y equal to how much, guys? Anyone? Y equal to how much? Y equal to, I can write 3, guys. Just to make it sigma B equal to E. E equal to how much, guys? 200 gigapascals. So 200 into 10 cube. Y equal, take care of the units, guys. Y equal how much, guys? 3 into 10 power minus 3. 3 into 10 power minus 3 itself by, tell me, sir, r. R equal to how much? I can say 1 meter plus, I can say this is the r. R should be what exactly? Till the radius of, till the axis of the beam itself, guys. I can write r equal to how much, guys? 1 meter plus 300 mm, guys. Sorry, 3 mm, guys, is the radius itself. 1 meter plus 0.003, guys. So I can approximately assume 1 meter itself, guys. So r equal to how much, guys? 1. So what is going to happen, guys? 10 cube and 10 power minus 3 getting cancelled out each other, guys. It is coming as 600 is the right answer. Option A is the correct one, guys. So I hope this is clear for you. Next, please go through this one. So very good question, guys. Please try, you can able to do it. Please try this question. Yeah, Upendra, it was a typo mistake. Upendra, it was a 17 amma. By mistake, it was given as a 2071. Are. Yes, please check it, guys. Please try this question, guys. Very good, Aravind. Pritesh, very good. Guys, try to be interactive in the class. Let's see, guys. A round uniformly tapered bar. A round uniformly tapered bar. Remember, guys, case number 5 we discussed in our classroom. Please verify our notes, you will understand, guys. A round uniformly tapered bar of length L and Young's modulus E has a diameter of D at one end, 2D at the other end, guys. This is the D, and capital D is given as how much, guys? Anyone? 2D, guys. At the other end, if the bar is pulled by an axial force F, here the bar is pulled by an axial force F itself. F, the extension produced will be equal to how much? What is the extension produced equal to how much, guys? See, listen carefully, sir. How can we find out? Observe carefully, guys. You know this formula. Deformation equal to how much, guys? Delta L equal to PL by AE. Na? P is same, which P means here F, guys. FL by AE. But here if it is a like prismatic bar, how much will be the A value, guys? Anyone? Pi by 4. Capital D into small d, right? Actual formula. Capital D into small d. Capital D is how much, guys? Anyone? 2D, and small d is small d itself into how much, guys? E. How much is coming? It is coming as a 2FL by pi d square E. 2FL by pi d square E, guys, or pi E d square, guys. The right answer here is what? Option A is the correct one, guys. Next, please go through this question. A very good question, guys. A solid metal bar of uniform diameter D and length L. There is a solid metal bar, guys, which is having a uniform diameter. This is a metal L, solid metal bar which is having a uniform diameter D, is hung vertically. It has given that rho E is the density, guys. Rho E is the density and E is the Young's modulus. Then total elongation due to self weight equal to how much, guys? You remember, guys, two cases I have discussed in the classroom. Please go through case number 6 and case number 7, guys. You will understand. So whenever, listen carefully, sir. Whenever, so I am having a completely prismatic. If it is completely prismatic, what is the deformation, guys? Anyone? Stand formula. Delta L equal to guys? Gamma L square by 2E. Gamma L square by 2E, guys. But what about conical bar? For conical bar, what happened? The weight of the conical bar is 1/3 of the weight of the cylinder. Yes or no? This is the conical bar, guys. That's why delta L for the conical bar equal to how much, guys? Anyone? Gamma L square by 6E, guys. But it is a cylindrical bar he has given, gamma L square by 2E, guys. But gamma means how much here? Gamma means weight density. Gamma means how much, guys? Rho times of G. Rho times of G. What is the formula he will be coming, guys? Here, tell me, sir. Everyone. Delta L of prismatic bar. Prismatic bar is how much, guys? Rho G L square by 2E. Which option is matching, guys? Anyone tell me, sir? Rho G L square by 2E means option B is matching, guys. I hope this is clear for you. Next, please go through this one. The relationship between linear elastic materials. Yes, please do this question. You can do it. Please try by using which formula, sir? Having three formulas I told you. E equal to 2G into 1 plus V. E equal to 3K into 1 minus 2V. E equal to 9 kg by 3 kg, guys. From that, please try and give me the answer, guys. This one. Meanwhile, let me drink some water also, guys. Try this question, guys. You can do it. You can do it, guys. Very good, Swapna. Darvat, Swapna Darvat. Please read it, guys. How can I find out? Same thing, guys. E equal to 9 kg by 3 kg, which means that 3k plus g, guys. 9 kg by 3 kg, guys. Just take it, amma. 3k plus g this side, 3k plus g this side by kg, not kg sale, amma. It is not kg sale and all. K means what exactly, sir? Bulk modulus of elasticity. G means rigidity modulus of elasticity. Okay, it is not 3 kg sale, Sravana masam sale, not, guys. 3k plus g by kg equal to how much, guys? 9 by e. 9 by e is fixed, amma. Now, 3k by kg, how much? Just go to divide this one, guys. How much is coming, guys? 3 by g is coming, plus g by kg is coming, how much, guys? 1 by k equal to 9 by e, guys. So which option is exactly matching here, guys? Option D is exactly matching here. I hope this is clear for you, guys. Very good, very good, very good, very good, Arjit, very good, Ronal, very good, Prince, very good, Krishna. That's great. Next, when a body is subjected to 3 mutually perpendicular stresses, when a body is subjected to 3 mutually perpendicular stresses is equal to, of equal intensity. Yes, guys, if a body is subjected to 3 equal stresses in all directions, guys, then ratio of direct stress to the volumetric strain is known as what exactly, sir? You remember, amma? You remember, guys, especially when we are defining about the bulk modulus, what I told you, guys, is one term is called hydrostatic stress, guys. What is the hydrostatic stress means? The stress is equal in all directions, guys. The stress is equal in all directions. I can write sigma x equal, tell me, sir, sigma y equal to sigma z equal to how much, guys? Sigma h itself, sigma h itself, guys. Then if I know the hydrostatic stress, guys, directly I can say hydrostatic stress directly changes the volume, guys. Directly changes the volume. That's why hydrostatic stress is directly proportional to volumetric strain. So what is the ratio, guys, here? Sigma h by volumetric strain must be equal how much, guys? Anyone? Bulk modulus. The right answer here is, guys, option C is the right answer, guys. That's great. Next one, guys. Very good. Next, please go through it, guys, everyone. Please go through it. Stress produced in a bar. Yeah. Please, I don't read it. You please read by yourself and give me the answer, guys. The stress produced in a bar by a suddenly applied load is dash times the one produced by the same load when the applied gradually, guys. The value of that x is how much, guys? The value of x. Please go through our strain energy topic, guys. Strain energy topic, they are clearly applied, guys. When the load is applied gradually, load is applied sudden, load is applied impact, guys. What are the difference of these 3 formulas? I clearly given. Go through our notes, guys. The strain energy topic, guys. In the strain energy topic, please go through it. I hope you can able to give the answer, guys. Very good, Arvind. Very good, very good. Yes. The right answer here is what exactly, sir? It is a twice, guys, because whenever I have applied, listen carefully, sir, whenever P is applied gradually, sir, P is applied gradually, what is the formula? Stress equal to P by A, guys, for the gradual, guys. Listen me, sir. For sudden, how much, guys, anyone? 2P by A, 2P by A, guys. Getting an answer, everyone, guys. If it is impact, what happens, amma? Stress due to impact equal to how much, guys? Same P by A into impact factor will be coming, guys. Square root of 1 plus 2h by delta gradual. So remember, this is called impact factor. You used to say, guys, it should be remembered. You should remember this formula, guys. How we got this formula, we clearly discussed in the classroom. Please go through our class notes, guys. So right answer here is what exactly? Twice, guys. Twice is coming due to sudden. Next, please go through it. Read it carefully, guys. Two circular mild steel bars. There are two circular mild steel bars, A and B, of equal lengths. Both are having the equal lengths, have diameters 2 centimeters and 3 centimeters respectively. Each is subject to a tensile load of magnitude T. Then the ratio of elongation of the bar. The ratio of elongation of the bars, guys. Sorry, so this is LB by LA, guys. The ratio of elongation of the bars, guys, which means that delta LB by delta LA equal to how much is asking, sir. But if you observe carefully, sir, here, what is the deformation formula? Delta L equal to what the formula, guys, everyone? PL by AE. Yes or no? Delta L equal to how much, guys? PL by AE itself, PL by AE. Now, if you observe carefully, sir, PL by AE, here P, tension is constant, length also constant, guys, equal length as given. Only, guys, he has given, guys, have a different diameter, so E also same, guys, same mild steel bar. So I can able to say delta A, delta LA into area of the first one, guys. That is, area of the first one is what exactly? Pi by 4 into how much, guys? 2 square into 2 square must be equal how much, guys? Delta LB into pi by 4 d, how much, guys, anyone? 3 square, guys, 3 square. Now pi by 4, pi by 4. So are getting cancelled, guys. It is coming as delta LB by delta LA means delta LB by delta LA means how much, guys, anyone? Tell me, sir. It equal to how much, guys? 4 by 9. Which option is matching, guys? Option C is matching here. Option C is matching here, guys. Next, please go through it, everyone. This question, guys. If A is the cross-section area, these three things, guys, should be very careful. There are three types of rigidities will be there. EI is called flexural rigidity. Tell me, sir. EI is called flexural rigidity. EA is called axial rigidity. GJ is called, tell me, sir, torsional rigidity, guys. Now, then please go through it, guys. A equal to cross-section area, E equal to Young's modulus, guys. Then torsional rigidity equal how much, guys? Without second thought, GJ. But such kind of questions you can answer very, very easily, guys. Next, a material with identical properties in all directions is termed as a material with identical properties in all directions is termed as, tell me, sir, elastic, composite, isotropic, plastic, guys. Here keyword is what exactly? All directions, guys. All directions. So it is called, tell me, sir, isotropic material. It is a isotropic material, guys. This is done. Next, please go through this question. Everyone, guys, read this question carefully. Try to answer it, guys. Let me also verify how many are active, guys. Very good. Good, good. Very good, Pritesh. Really doing good. Yes. The ratio of elongation in a prismatic bar due to its own weight was compared to another similar bar with the same weight. Getting us everyone guys? Listen carefully sir. The formula here is guys, everyone. The ratio of elongation in a prismatic bar due to its own weight. What is the elongation due to prismatic bar guys? Just now we given that equal to how much? Gamma L square by 2E. 2E guys, but gamma, but own weight na, weight equal to how much guys? I can write weight equal to gamma times of area multiplied by length L guys. So I can write gamma equal to how much is W by AL. Just substitute guys, gamma equal to how much? W by AL guys. If you put the gamma equal W by AL, 1L getting cancelled guys, I am going to get WL by 2AE I am going to get guys. If it is for what exactly? This is for self weight. This is okay. Now compare another similar bar with the same weight and an additional load of W at the free end in the direction of weight will be. The question is asking guys, a ratio of elongation of prismatic bar due to its own weight was compared to another similar bar. This is the another similar bar, listen carefully guys, this also having the same weight and an initial load of W at the free end guys. Here same free end is there and is also having the weight guys. Now first case, what the formula I can write down guys, delta LA equal WL by 2AE. Now delta LB, second case guys, second case what is going to happen? The deformation is coming due to self weight as well as due to end load guys. Due to self weight how much guys? Anyone? WL by 2AE plus due to end load how much guys? Anyone? WL by AE guys, because PL by AE itself. How much is coming sir? It is coming as 3WL by 2AE. Is asking ratio of delta A by delta B guys. So WLA by 2AE, WL by 2AE is coming as 1:3 is the right answer guys. Please verify. This is a little tricky question guys. Please, I hope you understand this one guys. This is a 2015 question number, this one. Very good, very good. Aravind, excellent Aravind. Prince, that's great. Next, please go through it guys, this question. A load P is applied to a wire of diameter D. The radius of the wire is doubled and reduce the load to half. Then Young's modulus will be, yes. Please go through and give me some very tricky question guys. You can answer not that much easily. Let us see how many students will be able to give the answer guys. Think, a load P is doubled, wire of diameter D, if the radius of wire is guys doubled and reduce the load to half, then its Young's modulus will be. Please check it guys, this question. Let us see how many students will give this answer. That's great Rodel, really great. Very good, very good, very good. Very good, very good. Answer how much guys? Remains unaffected. Why? Because guys, remains unaffected. Why? Because of, tell me sir. The reason here is guys, very simple. Young's modulus is a material property. Whether you increase the diameter or reduce the diameter, are you changing any material? No. You are not changing any material means no material properties will be changed guys. Which means guys, whether you try to simple logic, if I take a bigger steel bar or smaller steel bar guys, my property will be same or different guys. Young's modulus will be remain same itself. It's the same property, same material itself is there guys. I hope this is clear for you guys. Next, the property of metal by which it can be beaten or rolled into a thin plates is called. Tell me sir, it is called rolled into a thin plates. It is called malleability guys. If the same question is given, sir, drawn into a wires, it is called ductility. It is a malleability property guys. Then out of the following, which was having a unit of strain, guys? No unit. Strain doesn't have any unit, guys. Next, the material in which large deformation is possible before the rupture. The material in which large deformation is possible before the rupture, guys. Excellent, guys. Before the rupture, in which large deformation is possible, guys. Brittle, elastic, ductile or plastic, guys. Please tell me, sir. Before rupture. Very good, guys. Very good, very good. It is not plastic, it is whenever you see the large deformation before the rupture, guys, it must be a ductile material, guys. This must be a ductile material, guys. Ruptures, guys, it ruptures. So option is C answer, guys, not the D. Should be very careful, guys. Next, the point through which whole weight of the body acts is called. The point through which whole weight of the body is called. How simple question is, guys? It is the weight or gravity center, guys, center of gravity itself, guys. Civil engineering question, amma. Next, take the complex sum of the questions, guys. If two-dimensional stresses of the system, because one more thing, amma, in the entire, sir, if you ask me, sir, I don't have any time. I don't have any time. Tell me the topics where I have to focus more. Chapter 1, guys. As I told you while I am teaching in the class also, sir, simple stresses and strains. Suppose the 10 questions are coming, guys, 6 questions to 7 questions will be coming from simple stresses and strains only in all competitive examination except the gate exam, guys. Okay, in all, if you take SSC, if you take APPSC, TSPSC, ISRO, BARC, everywhere, guys, mostly, sir, first chapter is very, very important from all the exams point of view, guys. Focus more on the chapter 1, guys. Try to solve each and every question given in the PYQ, guys. One more thing, amma, most of the questions are repetitive kind of nature itself, guys. So don't think too much. You can able to solve the questions very easily, sir. First thing is go through all the PYQs, solve it, guys, before the examination. Okay, yes, let's start, guys. If two-dimensional stress system, the radius of the Mohr circle is represented what exactly, sir? What is the radius represent, guys? Radius equal to, tell me, sir, the maximum shear stress, guys. Radius equal to maximum shear stress. Without second thought, guys, answer is option D. Next, a body is subject direct tensile stress of 300 megapascal in one plane, accompanied by simple shear stress of 200 megapascal, then maximum normal stress will be. What is the maximum normal stress he is asking, guys? What the formula? Sigma 1 equal to how much? C plus R. Yes or no? What is C means what exactly, sir? Sigma x plus sigma y by 2 plus R means what exactly, guys? Square root of sigma x minus sigma y by 2 whole square plus tau xy whole square, guys. But here what happens, here sigma y will be equal to 0. Here also sigma y equal to 0. Why? Because he has given the stress only in one direction. He has given the stress, guys. This should be how much, guys? Sigma x by 2 means 300 by 2, sir. 300 by 2 means is 150 plus square root of how much, guys? Again 150 square plus tau xy how much, guys? Anyone, guys? 200 square, guys. 200 square, amma. How much is coming, guys? Please tell me, sir. 150 square plus 200 is coming as 250, I think, guys. So please verify, guys, how much is coming, amma. Should be 250. Answer should be how much, guys? 400 megapascal. Please verify. Are you getting same or not, guys? Everyone, please verify, guys. Yes, 400 into, yes, 250 plus 150, guys. It is a, yes, correct, Aravind. Very good, very good, very good. Next, along the principal plane subject to a maximum principal stresses. Along the principal plane subject to a maximum principal stresses. Yes, sir. Then maximum shear stress acts. Sorry, subject to maximum principal stresses. Maximum shear stress acts. Minimum shear stress acts. No shear stress acts. Partial shear stress acts, guys. Tell me, sir. I have stressed this point multiple times in the lecture, guys. You remember or not, sir? I told you, at the place of maximum principal stress or in the principal plane, I ask you to compare, guys. Principal is like your college principal, guys, and shear like his wife, assume for time's sake, sir. In the college chamber, in the principal chamber, his wife can come? No. Which means that in the principal plane is like principal office, guys. In the principal office, is there any possible of shear, guys? No. But if you go to maximum shear stress plane, guys, maximum shear stress plane, where is the maximum shear stress plane, guys? His house. That is a place where his wife stays, guys. That is the place I am having a maximum shear stress, amma. So at that maximum shear stress, after 5 o'clock is over, your principal has to go, na? Yes or no, guys? So normal stress exists. So in the maximum shear stress plane, normal stress exists. In the principal plane, tell me, sir, no shear stress exists, guys. I hope you remember, amma. This is the no shear stress exists, guys. One more thing. What is the value of normal stress in maximum shear stress plane? What is the value of normal stress in maximum shear stress plane, guys? Simple C formula, guys. What is C, guys? Anyone? Sigma x plus sigma y by 2 itself. Sigma x plus sigma y by 2, guys. Next. Go through it, guys. Bending moment at the free end of a cantilever beam of length L and constant W at the tip is how much, guys? Is asking. What is the at the free end is asking, at the free end, without second thought, guys, at the free end, bending moment equal to 0, guys. At the fixed end, I am going to get W into L, I am going to get the maximum bending moment itself. Yes. Next, the bending moment diagram of a cantilever subjected to a moment at the free end will be, tell me, sir, whenever cantilever beam subjected to a moment, guys, what is going to happen? Shear force will be 0. Complete shear force diagram doesn't exist, guys. Shear force diagram doesn't exist. But what about, guys, listen carefully, sir. Bending moment, guys, completely constant. You remember, guys, wherever shear force equal to 0, bending moment equal to constant, guys. I am going to have a, I'm sorry, guys, rectangular variation itself. Rectangular variation we are going to get, guys. Next, a simply supported beam of span L carries a total load W, which is uniformly distributed load. Then maximum bending moment equal to how much, guys? Guys, we remember in theory of simple bending, I given, guys, standard 8 formulas, amma. Refer any competitive exams, guys. Those 8 forms are very important. Like cantilever subject to point load, what is the maximum bending moment? Subjected to UDL, what is the maximum bending moment? Subjected to UVL, what is the maximum bending moment? Subject to like couple, what is the maximum bending moment? Simply support beam, subjected to point load, what is the maximum bending moment? UDL, what is the maximum bending moment, guys? These 2 cases are enough itself, guys. Remember or not, sir, everyone? See, subject to A, total load W, which is uniformly distributed, guys, uniformly distributed. Generally, sir, listen carefully, sir. What is going to happen, guys? This is the, assume the W dash, guys, length is L. Then you remember, guys, where is the maximum bending moment, guys? At the center itself, guys. How much is that value, sir? Anyone? You remember, guys, WL square by how much? 8 itself. W dash L square into L square by 8. But total load means how much, guys? Anyone? W dash into L equal to how much, guys? Total load. It is coming as WL by 8 is the answer, guys, maximum bending moment. Suppose same problem, they give the point load, amma. It should be what exactly, sir? PL by 4. PL by 4 is the maximum bending moment, guys. Please go through it. So those stand cases, guys, every civil and mechanical engineering student, guys, you have to go through those 8-9 formulas, guys. And one more thing, amma, in deflection of beams, I given the stand cases also, guys. In deflection of beams, subject to point load, what is the maximum deflection? PL cube by 3EI. Subjected to UDL, what is the maximum deflection, guys? WL square by 6EI. I hope you remember, guys, all these things, guys. Then simply subject to point load, how much, guys? PL cube by 48 EI, guys. UDL 5 by 384 WL for 4 by EI, guys. I hope this is standard cases, some of you have to remember, guys. I given 8 standard cases, guys. Again, in the deflection of beams, you have to go through it. Definitely one question will be coming in the ISRO. Just mark my words, guys. Out of this, either maximum bending moment formulas or maximum deflection formulas, guys. These 2 just to go through it before the examination. Out of this one question will definitely come, guys. Please go through it. Yes. Next. maximum bending moment in a simply supported beam of span L loaded with a constant at P at the center is how much, guys? Anyone? Maximum bending in a simply supported beam, guys, of span P. How much is the value, guys? Anyone, guys? Remember or not, sir? Just now I told you, sir, it's a PL by 4. If it is a UDL, WL square by 8, guys, for the UDL. For point, how much, guys? PL by 4 itself, guys. Next, the shape of a bending moment diagram over a length of a beam carrying uniformly distributed load is how much, guys? Remember, Amma, when load is UDL, guys, here load is completely UDL, Amma. When the load is EDL, shear force diagram is what exactly, guys? Linear. What about bending moment diagram, guys? 1 degree will be increased, parabolic itself, guys. The right answer here is option B is the correct one, guys. Next, the bending moment is maximum on a section of a beam where shear force is, tell me, sir, in general, if you take any beams, guys, where we get the maximum bending moment is, guys, wherever shear force changes sign, there is a place I am going to get a maximum bending moment, guys. So answer is option D, guys. Next, the strength of a section, beam section, primarily depends upon what, guys? The strength of a beam section primarily depends on what exactly, sir? Its cross section, section modulus, length alone, the external loading, guys. Without second thought, section modulus. You remember, guys, moment of resistance, guys. Moment of resistance equal to sigma allowable into Z. Z means section modulus, guys. When I can say this is called strength of a section, or section strength, or beam strength, all are having the same technical terms itself, guys. So whenever Z is more, automatically moment of resistance is more, guys. Getting an answer, everyone? So here right answer is what exactly? Section modulus. Next, when a beam is subject to a bending, the shear stress in the top fiber will be, think of it, guys. When a beam is subject to bending, the shear stress in the top fiber will be how much, guys? As I told you multiple number of times, top and bottom shear stress will be equal to 0. The right answer here is option C is the correct one, guys. Next, in a beam cross section, the bending stress is 0 at, tell me, sir, generally at the neutral axis, guys. At the neutral axis, I am going to have a 0 stress, guys. Next, the maximum shear stress in a rectangular section beam is dash times the average shear stress, guys. Again, standard cases, what is that one is, guys? For rectangular section is a 1.5 times of tau average. For circular, how much, guys? 4 by 3, 1.33 times of tau average. If you take a like a triangle, guys, at the center, h by 2, how much, guys? 1.5. Again, neutral axis, how much, guys? 1.33. Standard cases, you have to remember, guys. Rectangular means what exactly? 1.5 times of tau average, guys. Next, two solid shafts are made from same material and have diameter d and d by 2. The ratio of torque capacity of a bigger to smaller shaft is how much, guys? What the ratio of torque capacity, guys? Torque capacity. How can you find out torque capacity, guys? Which means the twisting strength he is asking, guys. Made of same material. What the formula generally, sir? You know this one, guys. Generally, sir, tau allowable equal to 16t by pi d cube, guys. 16t by pi d cube, amma. Here, tau equal, I can write tau allowable, tau r simply, guys, I can able to find out, guys, here. Tau allowable, material property is same, guys, into pi d cube by 16 itself. So this is the one, it is called, this is the one is called exactly twisting resistance. This is called polar section modulus, guys, pi d cube by 16. He is asking what exactly? Bigger to smaller, guys. Bigger is what? D, smaller is d by 2, sir. So I can able to write bigger, I can write torque capacity, guys, t by t smaller. This is the bigger, this is the smaller, guys. How much is coming up? I can write proportional d cube, na? D cube by, here how much, guys, anyone? D by 2 whole cube, guys. Answer is coming as 8, guys. The right answer here is option C is the right one. Next, the end of a deflection of a concrete cantilever beam with tip load W of effective length L, E is the Young's modulus, neglect the self weight is, guys. Deflection, how much, guys, without second thought, guys, WL cube by 3EI, it is a cube, guys, WL cube by 3EI. Next, the maximum deflection of a cantilever due to pure bending, yes, pure bending, how much amma? Standard cases, guys, please check. I have given due to pure bending m, L square by 2r, but 1 by r equal to how much, guys? M by EI, which means that ml square by how much, guys? Anyone? 2EI. If it is same thing is a simply supported beam, if it is a simply supported beam, this side is m, this side is m, guys, how much is coming, sir? L square by 8r, guys, which means that, guys, ml square by 8EI you will get, guys. All these things I have given as standard cases. Questions are directly coming from this one, guys. Okay, the answer is what, guys? Anyone? ml square by 2EI, guys. The right answer here is option D is the right one. Next, maximum deflection of a simply supported beam, guys. The right answer here is PL cube by 48 EI. This one direct straight for formulas, guys. Yes. With this, I have successfully finished my my task, guys. But this is just to give the motivation, amma. You can able to answer the questions with the classroom content, or with our ACE Academy required content, or ACE Academy live classes, guys. By watching all our regular lectures, you can able to answer all the questions, guys. I'm really happy that, guys, everyone was very active in the class and giving the answers, guys. I'm really happy for that. Really, guys. Good, good, good. Good, guys. Yes, guys, ISRO is having a bright future, amma. Think like, guys, if you are working from some private organization, you are working for you only, guys. If you are working for the ISRO means you are working for the development of our country. You are the future of our country, guys. Getting us, everyone, guys. You will definitely get the salary. Along with that, the pride of working for the country, guys. That pride will be coming if you are selected in the ISRO itself. So don't waste your time. Don't waste your time. Try to utilize the whatever time you are having wisely itself. Definitely, rank will be yours, amma. Have a positive mindset. If you are not able to solve, fine, you should feel very happy if you are not able to solve this. Why? Because you are having a opportunity to learn itself, guys. Because I have seen some of the students, guys, they get worried if they are not able to solve the questions. Fine, okay, this is not the final exam, na. You have to worry when you are not able to solve in the final examination, guys. So if you are not able to solve here, if you are committing a mistake here, you feel very happy that yes, you get the opportunity to learn itself. Try to learn from it, guys. If you stop learning, then that is a problem will be coming, guys. I hope everyone will be able to utilize the time properly, guys. I hope this session is very, very useful to you, guys. Thank you so much. With this, signing off, Hajratwali, guys. Thank you so much. Bye bye, guys.